For this project, ABC Bank aimed to improve the efficiency and constancy of its credit card approval process. Currently, approval are largely manual, rely on human analysis to evaluate each applications. So this process is time-consuming, potentially inconsistent, and the difficult to scale as the number of the application grow. So the objective of this project is to develop a machine learning classifier that can predict whether the credit card application should be approved. The model will support decision making while maintaining the transparency, fairness, and the regulatory compliance. In this context, the classification error have different business implication. A false positive means approval applicants who should be rejected, potentially expose the bank to the credit risk. A false negative means rejected qualified applicants, resulting lost revenue opportunities. So therefore, evaluation will consider multiple metrics beyond accuracy, including precision, record, F1 score, ROC, AUC, and balance accuracy to better capture model performance. We have 9,709 historical credit card applications and 20 features, including demographic, financial, and employment-related variables. The key variable including age, total income, years employed, account length with bank, housing, and occupation type. The target variables indicates whether a credit card application was approval 1 or rejected 0. Before modeling, several pre-processing steps were applied. The ID variables were removed since that doesn't contain predictive information. Categorical variables were encoded using binary encoding. Numerical variables were standardized to improve model stability. The data sets was split into a train and testing sets using stratified sampling to preserve the class distribution. So for target distribution, reveals a significant class imbalance. Most applications in the dataset were rejected, while only a small portion were approved. This imbalance presents a challenge for machine learning model, a naive model that always predict a rejection while still achieve high accuracy, and we are failing to identify approval applicants. So because of this imbalance, we rely on additional metrics such as record, F1 score, and the balance accuracy rather than just accuracy alone. In this context, record is particularly important because fail to identify qualified applicants may result a missing revenue opportunity for the bank. Based on the right here, based on several machine learning models were revealed, evaluated using cross-validation, including logistic regression, decision tree, random forest, LightGBM, XGBoost, a natural network. Each of the model evaluated using the following metrics: accuracy, precision, record, F1 score, ROC, AUC, and balance accuracy. The evaluation metrics including all these things, and the result shows the logistic regression achieved the highest F1 score among the test model. So many tree-based model produce extremely low record value, and this occurs because the dataset is highly imbalanced, causing several model to predict almost all the observation as majority class rejection. The result indicates that logistic regression gives the highest F1 score. So as a result, all this model achieve high accuracy but fail to correctly identify approved applicants. Based on the accuracy, about 86.6%. It's the accuracy on the test set. However, a further evaluation reveals that the model predict near all the applicants are rejected. So as the result, The precision for approval clause is zero. Record for um, approval clause is also zero. F1 score is zero as well. This highlights a common issue in imbalance classification problem. Accuracy alone can be misleading. While the model appears accurate, it fails to correctly identify approved applicants, make it unsuitable as the standalone decision-making system without further adjustment. This demonstrates why relying on the accuracy can produce a misleading conduction when the dataset is highly imbalanced. Additional evaluation metrics such as recall F1 score and the balance accuracy are necessary to better understand the model performance. And the learning curve um, shows a large gap between training performance and the validation performance. The training F1 score starts very high and decrease as the data sets grow. Well, this means but the validation score remains extremely low as all the time. And this pattern suggests that model is overfitting the trained data set, and the model suggests to generalize a struggle to generalize actually the unseen data, and the imbalance in the data set heavily affect the prediction behavior. So this result reinforce the need for careful model selection and the fairness analysis. So for the fairness analysis, um, ensure the fairness is particularly important in financial decision due to the regulatory requirement around the fair lending practice. To evaluate fairness, we examine the predictive approval rate across gender group, and the results show that the predict approve rate is extremely low for both gender group, with slightly high rate for gender one. However, because of the model rarely predict approval for any applicants, the difference are minimal. This reduces the risk directly gender discrimination in prediction. It also indicates the model is not efficiently identify approved applicants overall. So potential mitigation strategy including rebalance methods such as SMOTE or adjusting the classification threshold or applying class weights during the training. These techniques may help to improve the model's ability to detect approved applicants while maintaining the fairness across the demographic groups. And for the loss summary plot, we have so to improve the transparency, interpretability, and explainable AI techniques were applied. A sharp analysis were used to understand which variable most strongly influence the model prediction. And the result shows that more influential features, including account length with the bank, age, total income, years employed. All these variables align with the credit card risk. Typical credit card risk indicators are using the financial decision making. Applicants with longer relationship with bank, stable employment history, and higher income level tend to have a good or higher probability of approval. A longer relationship with bank and stable employment history generally contributes positive to the approval likelihood. So this actually makes sense. So overall, this project developed a machine learning model to assess ABC Bank to evaluate the credit card in application. And multiple models were tested, including logistic regression, random forest, uh, guiding the boosting model, and neural network. Due to the strong clause imbalance in the dataset, several models achieve high accuracy but fail to correctly identify approval applicants. Logistic regression achieved the highest F1 score among the testing model and provide strong interpretability. Model evaluation reveals that accuracy alone is insufficient for this business problem. Metrics such as recall F1 score and balance accuracy provides a more realistic assessment of the model performance. Fairness analysis shows the minimum difference in approval rate between the gender group, although the model rarely predict the approval overall as well. Um, so explainability techniques such as SHAP and LIME were used to identify the key drivers of credit card approval decision. The most important factors including the account length with the bank, income level, age, and employment stability. Based on all these findings, the model should be deployed as a decision support system rather than just a fully automatic approval engine. Human oversight should be remain a part of this process, and particularly for the borderline cases to ensure the responsible and transparent and the compliance decision making.